right. Hello, everyone. Hello. Thank you all for joining our session today. We got some really cool stuff to talk about. My name's Peter, and I'm the VP of Mobile Engineering at Age of Learning. This is my good buddy Ray. He's going to introduce himself shortly. But before we get to that, I wanted to talk a little bit about Age of Learning and why I think we're pretty cool as well. And why this thing's pretty cool as well. There we go. Perfect. Thanks, Ray. Okay. Age of Learning was founded in 2007 by our CEO, Doug Doring, and his long-standing management team. Has anyone here ever heard of Neopets? Yes? Yeah? A few people? Cool. All right. Well, in 2005, it was considered the stickiest site on the web, and today consistently ranks within the top 10. These are the guys that founded, scaled, and sold it to Viacom, after which Age of Learning was born. The team spent nearly 4 years developing educational content and experiences, and in 2010, Early Learning Academy, or ABC Mouse, was launched. We're now well over 600 employees, consisting of artists, animators, producers, directors, PhDs, and some of the brightest and most creative minds in the industry. We have over 30 Unity engineers and 10 technical artists on our team, and we're looking for more. Thank you. Everyone at Age of Learning is super passionate and aligned around a single mission. That mission is to help children everywhere build a strong foundation for future academic success. We are always super interested in meeting people that share this same passion. ABC Mouse is the leading and most comprehensive digital learning resource for children between the ages of 2 to 8. We're creating some super new, awesome products right now aimed at focusing on older age groups as well. We're constantly innovating and we're constantly growing. We've been the #1 top grossing app in both the education and kids categories for the past 3 years. In mid-2015, we launched our first app in China, and we're #1 top grossing there as well. Now, some might argue a big part of academic success is thanks to teachers and classrooms. We certainly think so. We offer ABC Mouse free to all teachers, with 65,000 using it actively in their classrooms across the country. In addition to classrooms, families with lower incomes rely on libraries for things like access to the internet. Right now, over 6,000 libraries are also using ABC Mouse for free. Okay, with that, I'm going to hand it over to Ray here to talk more about how we're harnessing the power of Unity to innovate and push the limits of creativity and engineering within Age of Learning. Take it away, Ray.
All right, thanks for the intro, Peter. So my name is Ray Barrera. I'm Director of Engineering at Age of Learning, working primarily on ABC Mouse. Then I'm going to talk to you a little bit about some of the things that we've discovered are some of the crucial differences between developing an app and a game. Obviously, it doesn't mean that there's absolutely no crossover here, but there are some key differences and some things about how we built our app specifically that might be useful to some of you guys. So identified a few of the key differences. So for example, our application is heavily dependent on UGUI. We built the majority of our app on top of the UI layer. And so if we were doing this a few years ago before UGUI, it would have been a little bit trickier. There were obviously things like NGUI and stuff like that, but we make heavy use of all the features that Unity has provided out of the box. And so we've built everything to be event-based and data-driven. That's another difference, is that we're not really checking for things in the update loop. We're not really, we're not concerned with where enemies are in position and stuff and AI and all this other stuff. It's really the user, the kid, interacting with the app, displaying some data, getting some data back, doing stuff with that, and doing it in a way that is engaging. So the other thing is our process. So our process is a little bit different in how we develop the app and how we've structured our project. We have what we call dynamic project structure, which means we're able to take one code base and we're able to package it up in different ways. And I'll talk a little bit more about these things as we go on. The other thing is we ship things modularly. And by that I mean we're shipping the binary to the app stores. We're shipping our APIs separately. We ship the desktop version of ABC Mouse is actually on a full browser stack, so that goes out separately. And on top of that, we're able to publish content. So our content creators can create new content every day without requiring any intervention from a developer. So able to just push new content out, and I'll go over what that means. And unlike other processes, our developers work a lot in their IDE, just writing code. Our tech artists are primarily the ones taking on the editor work. They're the ones creating prefabs and placing things and anchoring stuff. And our developers are writing code against that. And some of the skills that we look for are somewhat, not unique, but these are not necessarily things that you use often in games. So there's various design patterns that just don't make sense in games that we use a lot, and I'll go over those later. Our 2D, 3D tech art pipeline is sort of unique. Again, because we built everything on the UI layer, we sort of fake a lot of 2D through our 3D stuff, and we made some pretty cool custom stuff that allows us to take advantage of sorting and anchoring and stuff like that, and some procedural meshes to do UI elements. And we work in a service-based approach. So when I talk about the UI layer, I think something like 90% of all the different sections are built on top of the UI layer. Here you can see an example of that, where we're combining a lot of different things. There's particle systems going on, there's animations, and there's some buttons. And this works great on all different device screen aspect ratios and resolutions. So we have activities that are interactive. We've even built those on top of the UI. So for example, we have a jigsaw puzzle engine and a cutout puzzle engine, and those entirely built on top of the UI. We make copious use of the canvas scaler, and we've written some custom scripts that will sort of switch whether you're scaling by width or height. By default in the inspector, you're able to set that once, but sometimes we need to adjust that based on whether or not you have like a static set of content or a dynamic set of content. I'll explain a little bit more about that. Another thing we're able to do by working in the UI layer is that we can make certain sections have a native feel. They look native, they feel native. A lot of the components are things you would expect, like checkboxes and toggles, input boxes and date pickers and stuff like that. It's very performant, it's super flexible because it's data-driven. So we're able to, for example, in that middle screenshot, we're able to say, maybe we don't want one of those buttons. By just disabling the data, it just won't draw. So we're able to move things around fairly easily. And this is something that the team has been working hard at making more and more flexible. So a lot of the data will just load in from the API. And again, because it's all data-driven, it's also localized. So we're able to swap out the text. In the example that for a Chinese product, this is actually out of our Chinese product. So we're able to have the English text and content or the Chinese or Mandarin. OK, and so here's an example of that. So our layouts are, again, using the same assets. We're able to do both our 4x3 tablet layout and our 16:9 phone layout. So same buttons, except on the left side you have 5 different buttons. There's one on the right side that just doesn't fit. We didn't want to scale it or make it look weird. So we move it into the hamburger menu. But we're using the exact same assets. Same thing for the map. The map is static content. It doesn't actually have any stretchy content. It's just like a painting, right? There's some hotspots on it. But we were able to come up with a nice system that has a safe zone so that we know no matter how we crop or if we scale, we're not going to lose any of the touchable hotspots that the kid will interact with. When it comes to code, we do a very modular design. We like to think of it as Lego blocks where we can take pieces and move them around. So here we have an example where we have the classroom and our subject pages and all these different sections of the application. And they're all bound together by this series of libraries that we call Unity Core. Some of it is literally in a repository. We use Git submodules for this. But we're now starting to move to a different structure, which I'll go over in a bit. But essentially, yeah, this is either the library core itself or a set of shared libraries that we can use in ABC Mouse and in other places. The most important of these is the web services component, because our app, it's a dumb client, essentially. We try to move as much of the business logic out of the client and up to the server so that we can say, instead of going to this location as your home page, we can change that and say that it's a different location. And we can swap those out on the fly. That helps us do things like A/B testing. We're just pushing contents. We rely heavily on bundles, and I'll talk about that a bit more as well.
And also builds, not having to submit a new build to the respective app stores. It makes it really easy to change stuff without having to go through that approval process.
Yep. OK, and so this is more of what we're moving towards. So in the past, so we use Git. We rely heavily on submodules. So every component is a submodule. We just pull it into the main repository for the project. Something that we found is that's a challenging way to work because we have so many different teams that are all working on the same product. And so it's difficult to know when to make changes that are safe in one place that might not break somewhere else. So we're moving to something that's a little bit more streamlined. It's a flat project structure. So we'll have, for example, feature A. There's a DLL in there. So now we're compiling all our code into DLLs. That makes your compile times faster in the main project, and it also makes it so you don't have to re-QA the whole thing over and over when you make changes outside of it. You know that there's not going to be regressions because that code's kind of locked in. And then we move the assets into these separate folders, one for each variant, and I'll talk about that next. And then we throw out packages from this. So this allows us to automate it. We can build packages in an automated way and go through a CI process where we know we've QA'd this chunk of code and this feature, and it's ready to go out. And we can share it with different applications if we need to. And something new that we're starting to roll out is NuGet packages. So now we don't have to really even manage the dependencies manually. The NuGet package will have dependencies to other areas and other components, and those get pulled in on their own. So we have the flavor system that will help us take this one chunk of code and flavor it up. We use the term flavors. We borrow that from Android, if you're familiar with Android development. The other option was to use build targets, because iOS uses that, but that means something different for Unity, so it'd be a little confusing. So we went with flavors. Flavors just means it's a variation of the app packaged up with different assets. And so what we did is, rather than trying to maintain different branches with different content, we do it all in the same branch, all in the same place. And we say, we're going to create these flavor folders that contain only the relevant assets for each different variant. So for example, we have our CN app, our JP app, Japan, and then our US app. And then we dynamically link the proper assets using symlinks. So we're able to say, because we're working on a CN app, we're going to pull in only the resources folder out of the CN app. And we use this technique that is not widely known. I guess in Unity, if you prefix a directory with a period or a tilde, it just will be ignored by the project folder. So everything can be in source control, and it can be shared with the rest of the team, but Unity doesn't necessarily have to know that it's being used because you're symlinking it to a different location, and that's where it shows up. Just think of it as like a symlink is basically like a shortcut on your desktop or something like that. And so the team, some of them who are here today, got a little carried away with the concept of flavors. The tool is called Flavortown. There was a lot of references to Guy Fieri in there. Maybe one or two references to Flavor Flav. But anyway, this tool basically helps automate a lot of those processes. So switching symlinks is not you going into command line and like creating the symlinks and moving them around. It's just this tool will do it for you. So highly encourage tooling around these processes, because having to do this manually every time is just not feasible for a big team. If you create a tool once, spend a few days, you're good to go. OK, so asset bundle, something I touched on earlier. We're able to publish content, as Peter said, without submitting a new binary for things that we've already built. So we build things in a way that are data-driven. So we can consume, for example, the puzzle example I gave earlier. Our puzzles, the artist will begin with a source file. It's a SWIFT or a Flash file or something. Through some magical process, it becomes a PSD. There's many converters out there. And then we're able to pull information out of the layers in the PSD file. And so we put it through this process where it goes into this machine. It looks like that. It's in the office.
It looks exactly like that.
And so it does a few things. It takes the content, some parameters given by the content creator, and it creates a puzzle. How many pieces go into it, what the sound effects that go with each click and all that. And then it writes that information to the database, and it saves the assets to our CDN, essentially. And then through a separate process, we call a bundling process. So we have automation machines that just kind of sit around doing bundles all day. It's a very boring life for them. But essentially, they go through, anytime you publish a new piece of content, it'll go through, it'll create a bundle out of it, move it to the right location. And the way we do that is these are running on Unix machines, so we can just mount a drive and have it drop it off somewhere. Our bundling process is some custom code that we wrote just for building bundles through command line. It'll just call a headless version of Unity, run the bundling asset bundle pipeline scripts or whatever it's called, just using the public Unity APIs, and then it'll put out a bundle or a series of bundles in the location that you specify. So yeah, then we move these up, and then essentially we can make that content live by pushing some content to our production servers, and then users will automatically get the new puzzles or the new songs or books or what have you.
I just wanted to add, asset bundles are super important for us. We have over 80 gigs of content. So in order to ship all that content with the app is just, it's not feasible, it's not possible. Yeah. So leveraging the power of asset bundles has been something, it's been an integral part of our entire workflow and architecture.
Yeah, exactly. Okay, and so when it comes to code, I promise you I didn't just vomit out random letters onto the screen there. These are things that we actually use. So the reason I put these specifically up there is because even though they do have uses in game development, they're not quite as widely used as they probably should be. But in app development, these are kind of your bread and butter, MVC, MVVM, whatever we're using. For us, we use that for our art activities. And we're starting to roll out across different features, inversion of control and dependency injection. So again, going back to the Lego pieces that are modular and totally portable and you can move into different places, that's how we do it. And so we adhere to a few different principles like solid and dry. Don't ask me what every letter of solid means. I don't remember. You can Google it. And some pub/sub patterns. Some of the other stuff that we're starting to use, looking into anyway. We're not rolling these out yet, but it's unit testing, integration testing, et cetera, et cetera. Those are important because, again, we want to automate as much of this as we can, and having to go back and manually QA things where we tweaked one thing is just not a good use of time. And so if we can automate this to Unity's unit testing tools or something like NUnit, vanilla, we can save a lot of iteration cycles and just really have that peace of mind that nothing broke that we didn't intend to change. And again, this is something that's a little tricky to do with games because we have such a concrete piece of software where it's like, here's the data, here's the view, here's this. We know exactly what to expect, and it makes it easier to write these tests. And the other thing I mentioned was our tech art pipeline. So we've had to get creative. Our tech artists have been very, very creative with some of the solutions that they've found. For us, we're primarily bound by memory. We target older devices because a lot of our users are younger, they're kids, and they get the hand-me-downs and stuff like that, or like the $50 tablet from Toys R Us. Not a lot of memory in those. So we try to shy away, we move away from heavy textures and that as much as we can. And so for animations, rather than relying on something like a PNG strip, where you just have a frame-by-frame sequence of animations and you go through it, a little bit of modification to SVG importer, we're able to just use SVGs, and I say SVGs because they're essentially turned into meshes. I think they're imported. I don't think it's at runtime. But we play the sequence. So let's see here. There we go. And you can see ABC Mouse's mouth is moving. So we're iterating through these different mouth shapes here. And it's all based on this animation file here at the bottom. It's a little hard to see on the screen, but it's just a Unity animation. It's just saying which of those frames to play. And because we're less CPU bound, we're OK with that trade-off of having to do this on SVGs. It's really fast. And it doesn't use a lot of memory or take up a lot of space on disk. Another example. So this looks a little weird. I'll show you what the result is. But essentially, another challenge, again, was using 3D stuff in the canvas. Sorting and anchoring and all that sort of stuff, a little tricky. So we wrote some custom stuff to support our own custom meshes in the canvas. It's fairly straightforward to do, but it took us a long time to figure out how, and our team spent a long time on it. But the results are really awesome. So you'll notice we're using, if you've ever used TextMesh Pro, those little T's are TextMesh Pro icons. That means we're using TextMesh Pro there. The advantages we get here is that everything scales to whatever size you want it to, and the file size is really tiny. Again, it's on CPU as opposed to memory and in traditional ways of doing this. So it looks really crisp. It looks beautiful no matter what resolution you're doing it on. It's important for us, again, because in mobile in general, different screen sizes, resolutions, densities, yada, yada, even weird iPhone 10 notches and stuff. You want to keep it dynamic. So the result is this. So this is what the pop-up looks like. There's no content in the back, that's why it's black, but essentially the UI, the HUD itself, is a combination of different things. So we have our GIF box, which is a 3D object, and then we have some rays coming out of it, and there's some particles even. All of that is in the canvas layer. All the sorting works properly. Scale it to whatever size you want. Another great thing we do is that if we want to recolor this, we have a shader that lets us pick the colors for every part of it, and it does it on the fly. So you can change whatever color you want, and you have one set of little tiny data-based assets. Same thing with the text. And there's a few textures here and there. This doesn't work for everything. It's not a catch-all. Obviously, if you have a painterly looking UI or you need some more detail than what something that's SVG-like will give you, you're going to need to use textures. But this lets you lay down a base level groundwork that you can build upon. And so we tie it all in with our CI/CD pipeline. There's one icon here missing, but I'll talk about it. So we bring it all together with Git. We use Git, and then we have our own hosted solution for GitLab. And so when we push to the repo, and we want to put out a new build for QA, Jenkins will get that event. It'll kick off a build. That'll invoke, we have 2 different jobs, and we have different machines on site. Fortunately, we haven't been able to use Unity Cloud Build reliably. But this is a really great solution because it gives you full control over the hardware you're using and the build times, and you know what to expect because you're not sharing this hardware with anybody else. So essentially, you'll kick off a build. We have this custom system called Monolith, which allows us to modify the Xcode project before it builds. If you've ever done any Xcode development, or sorry, iOS development in Unity, you just get an Xcode project at the end and you build that. For us, we've actually had to make some changes. We support some features, some additional capabilities that are not default.
Like deep linking, single sign-on, XAuth.
Yeah,
These
so
kind
that's
of
like
things make it a little more difficult.
shared keychains and app groups and stuff like that. So you have to, it's literally just you clicking a button in Xcode. But if you're going to automate it, obviously it's not an option. So Monolith will read those settings, write them out to the PBX project, to the Xcode project, and then we build it through command line. X209 has been really great for automatic signing. I recommend you move to it quickly because it removes some of the stupid design decisions in 8, like a fix it now button that breaks everything for everyone.
It's awesome.
Yeah.
It's the best button ever.
We're happy with that. So we'll generate our documentation, and then we'll end up with an IPA or an APK, and we upload that, again, through Jenkins entirely. It's completely automated. We throw that up onto Hockey App. And if you're not familiar with Hockey App, it's kind of like a test flight, but it also works for Android, and it's actually owned by Microsoft, I think.
Yep.
Which is great. It's just hosting builds and stuff like that, and you can have distribution lists. And so we'll send out messages to Slack and to the different emails. People get their builds, and off you go. Doesn't tie up a developer anymore to have to sit there and do builds and wait 20 minutes while Unity imports stuff. You just kick it off to another machine and do it that way. We're starting to experiment with some Docker stuff. We want to really virtualize a lot of this instead of being bound to like hard instances of stuff. So we're starting to experiment with some of that stuff. Looking forward to see how that progresses. So that's all I have for the technical stuff. I wanted to throw it back to Peter. I know he has some cool stuff to share.
There's a few last things. Thank you, Ray. I'd like to quickly wrap up here. Fun stuff. We're always looking for great people. Please check out our website. If you haven't visited our booth yet, go by the booth. We've got the coolest swag in the conference. Thank you, Miriam. And there's lots more info there as well. Our offices are state-of-the-art. We're located in beautiful Glendale, California, and we've got great relocation packages if anyone's thinking about making a move. We're always doing fun things and having a great time doing them. You can see here, we work with the city to block off the street so all the best food trucks in town could come by and set up and let us sample their wares. There's also a couple things we take pretty seriously at Age of Learning. One of them is cake. So every month, we have a cake day to celebrate the birthdays for that month. Look at that cake. That's not a hamburger or a bucket of beer. That is a delicious cake. It's a work of art as well. So we celebrate these cake days and quite fond of that every month. The second is Star Wars. So for the past 2 Star Wars premieres, we've rented out the famous El Capitan Theater in Hollywood, and we've had the entire company and family members come down and enjoy the premiere on opening day. Once in a while, even Darth Vader himself shows up to say hello. This guy here, he broke the build. So that's what happens when you break the build. Okay, finally. To date, over 10 million children across the planet have used ABC Mouse. It's pretty big, right? This is Age of Learning. Thank you.
And so,
you go ahead.
yeah, we have a few minutes left, so we definitely want to open up for questions. If anybody has any questions, please come up to the mics and we'll get your questions answered. And by the way, here's some information where you can reach us. If you have any questions, feel free to reach out. Again, we're at the booth downstairs, and you can come by and say hi. What's your question? Uh-oh.
Hello.
There we go.
Yeah, so I had some questions around how you were leveraging Unity to build out some UI components, like mobile or in web, where you see a lot of standardization, and how you expect an Apple device to work or an Android device to work, and the different interactions you have there. So how do you approach that in some of the applications you guys are building?
And I think that really starts with the UX step, making sure that your flow is consistent. Obviously, you'll have differences like the back button not being present on one device but on the other, so we just always assume you need a back button. We have a really simplified interface because our users are kids, so we like to streamline things, make buttons nice, big, and pressable, and everything you hover over will have a voiceover so that the kids know what they're tapping on, because our kids can't read yet, they're learning how.
Sure.
So there's a few things that we do like that, but as far in terms of how we do it for different devices, it's really Unity's anchoring and scaling system does most of the work for us. The canvas scaler saves us so much work. Just,
Yeah, that's a big one.
You set it to the right settings, you build to any device, and generally it looks okay. There are a few plugins on the Asset Store that help with previewing, like XARM, I think that's what it's called.
Yeah, that's a good
You
one.
can see every single resolution that you want to see on the fly.
So a lot of your UI is custom built, not necessarily like adhering to, let's say, material design or Apple's standards, right?
Correct, it's entirely custom.
Yeah.
Yeah.
Okay.
Yeah. Although we do look for certain things, like in the parent section that I showed, we do borrow a little bit, but it's not officially either one or the other. Yeah.
Thank you.
Thank you. Hey.
Hi. Sorry. You mentioned heavy use of asset bundles, and I could be wrong, but my understanding was that there are potentially compatibility issues across versions of Unity. How do you deal with that?
So you don't have that many issues going from version to version. Unity is pretty good about maintaining that backwards compatibility. It's more likely that a developer will break those asset bundles. And so this is a key takeaway is if you want to make changes to asset bundles, for the most part it's okay. Just don't change, if you have scripts in there, don't change anything that's serialized or use the formerly serialized as attribute in the code, and that'll make sure that you're not breaking the type tree and breaking the bundles. But as far as versions go, we had a machine running for like a year on the same version of Unity, even as we moved the project forward, and it was okay. The biggest difference being from Unity 4 to 5, that was like, they knew they were breaking it, and so we had to make changes for that. But generally,
we also version our bundles too, so when we're
Yeah.
making a change, we actually version up, and so we don't break backwards compatibility.
so that's an important point, is we have additional metadata in our bundles on top of what Unity gives you, just so we know some additional stuff, when we built it, what version it's in, if it's a permanent bundle or not. And that's just a little system built on top of Unity's, a very lightweight system for tagging things and creating a JSON file that tells you these things.
Thank you.
Yeah. Thank you.
I know you're primarily focused on mobile, but have you done much yet using WebGL? And if so, what kind of things have you run into? Because I've also been doing this app type stuff, but in
Let
Unity.
me start on this one.
Sure.
Yeah, so we've played with WebGL. We looked at actually redoing our kind of website in WebGL. A couple problems are initial load times, so loading all, and you got to load it all the time too, right? Like if I make one change, it's just, and those load times can be, and there's a lot that we're loading. And the second issue that we faced was browser compatibility. So being in libraries, being in schools, they don't update their browsers quite as quickly as, say you or I might. And so having that, being able to access all those same resources without forcing a school or a library to update their browser to the latest and greatest ended up being kind of a blocking problem for us as well.
Makes sense.
Yeah. So we went with a native pipe. Everything's a full web stack on the desktop side of things. It's Angular and JS and stuff like that.
Cool. Have you had any problems keeping those at parity?
It's always a challenge.
Yeah, definitely. It's always a challenge. It is.
Yeah. And in fact, we went from a hybrid approach previously where we were in part native, part WebView, and part Unity. And that was its own challenge, just the two platforms natively. So that's why we went to Unity, to keep the parity, at least within mobile, iOS, Android, and potentially other platforms.
Great. Thanks.
Yeah. Thank you. Hello.
Hello. Do any of your apps use any push notifications?
So we experimented with push notifications for our China product. And I think the goal of it was to kind of drive parent engagement. And so we would send them a notification, at whatever interval saying, hey, your child has completed so many activities, in the past X hours or days. Congratulations, keep up the good work. And the hope was to drive the parent to encourage the child to continue to, learn and grow and complete more activities. And in fact, it had kind of an opposite effect. So we ended up seeing a lot of, members kind of drop off with these notifications. I don't know if it was an irritation factor or what it was, but it had a negative impact on our users.
Can you talk a little bit about, like, when you were doing it, the technical things that you ran into as problems? Because I ended up on mine switching to Android Studio. That just ran into so much trouble trying to get push notifications to work in Unity.
So we played with a few different plugins. The one that we landed on in the end was the Amazon. It's the, what is it? Simple
SNS, I think.
Something like that, yeah. And that seemed to be, work really well. The main issue that we faced wasn't getting it to work in Unity. It was getting it to work in China. So getting past the Great Firewall of China was very, very difficult. But Amazon had, some backdoors or some ways that made that available to us. And so we were able to implement it relatively easily in the end. Yeah.
So we're out of
sorry.
time, but if you have any other questions, we'll be right
Yeah, we're
outside.
hanging
Come
around
by our
here,
booth.
so,
We'll
yep.
be more than happy to chat with you. Thank you.
Yep, thank you. Thanks, everyone.